I forget to hit that recording button. All right, I just because I'm already thinking about something else. Well, anyway, let's do this. Make sure that we build it. Make sure it's cleanly built. And in this environment, because if you look, if we take a look at our project, it's on my D drive. Standard list demo. If you look at this SDF file, this is actually a SQL Server database of the of our project, with all the source code involved and being organized into this lookup database for this environment. It makes it possible in this environment to say right click and say go to the definition and show me. Right? So it suddenly opens the list header file and takes you to the list class. And if we just take a quick look into this, this is what internally is defined here. So class list is defined. It's a template. We will talk about templates in the future, but it's a template list, and it also derives from another object. And it's also a bidirectional link list. And let me see. So there is a node internally in there. For example, if we go to the object from which we derive here and say go to definition, it's actually another implementation file that exists here, and somewhere here it oh, it actually derives from the node. That's the way it's organized. So let me go to the definition of this one, and this is the node of the list, and it happens to be part of. So without knowing it, it's funny enough that without knowing it, it names itself list. But if you carefully look at the implementation, you're actually using interface to the node object. And just to show you that the beauty of a standard library is that all of its source code is available, and in fact the structure node is defined within this class. And also I was expecting to see an iterator, so somewhere here an iterator is also defined. And sure enough, there will be insert and other remove, insert, and all of these functions internally. So it really doesn't do anything different, rather than it makes this node, what complicates the syntax inside there, that this is a template. In fact, using templates is very simple. Coding them and creating your own templates is somewhat difficult, but it's not that bad. So again, we will cover standard library facilities, containers of the standard library, a string of the standard library, iterators. We'll look at more of the iterator interface in the future. And of course, we also will talk about the templates in the future. So this is still to come. But this sort of gives us the look and feel for the list that comes from the standard library and its implementation. Where I wouldn't use it is the situation where, for instance, I'll give you an example where this becomes sort of useless. If I have a game, right? If I have a game, and I create some characters here, right? So there are some characters that I use in the game, and some structures that I use in the game, right? Like buildings, and maybe a car here, right? Something like that. So I could create multiple copies of characters, right? So I could have multiple characters in the game. I can have many different structures, right? So additional structures. And of course I can have multiple cars and things like that. Just create them. Right? So I have all of this in this world. And every single piece here is represented by, I kind of messed up this guy right here. So I'll try my best to do it. The thing is that, what if this is the program that's supposed to manipulate all of these objects. Is this a challenge? Obviously, yes, it is a challenge. Well, guess what? If somehow I found a way to, anytime I create a new thing here, maybe I don't create it in isolation. Maybe this thing should join the list of already existing objects. And then this should be linking to this should be linking to this, arguably in the order in which they were created. If I do maintain a list of those things, just like this, right? That's supposed to be an arrow. And this one eventually pointing back to this one, then I could choose any object I want and say, hey, take this message, right? Take this message. For example, you're supposed to explode. There is a bomb went off near you. You will now explode, so do it, right? So I send a message, and this guy actually says, oh, by the way, near me there are other objects. So it can explode itself, but also send a message to the next one, to the next one, to the next one, to the next one, so they will all explode. And eventually, this circle completes. And this is called then circularly linked list, so that when the message is sent, if this message further is propagated to the next object on this list, and of course in my case I'm using this list for communication, because now I can send messages, like I can choose any object and say, take this message. Some messages can be sent to individual instances, and some messages can be sent to the entire set of objects. So it's great in communication, and it's great in designing games and other highly interactive environments. So then, if on the circular list I would like to send a message to all objects, I need to find a way to stop this set of calls. When this object eventually delivers this message to me, I need to be able to say, oh, wait a minute, I was the one who was initially sending this message down the list. So now this is it, stop, right? So we will no longer propagate this message because we made the full circle. This is called circularly linked list, right? And therefore we just return from this call, and we return and we return and we return. Eventually we return and we return to the original caller and say, okay, done. Message is being delivered to all of them. So it's very nice to just to know that this is the way where suddenly, if you need something like this and you need to rely on a list for communication reasons, then this is no longer your choice. You have to go back to our first project where we had a node with a useful payload, and then by the way, I can quickly basically show you another possibility for this design. Let me clean this up. And supposedly so I have many different things here, a car, right? And then structure, and then character, and I have quite many of them, right? So I have a ton of them, maybe 1,000 of them. So what I can do here is that I can create a node for each one of them separately, right? And this time, for communication reasons, we're using circular linked list, like this, which is topic of our next discussion. But remember the payload? Well, the payload could be just a pointer to every single object like that. So when I create my characters and buildings and things like that, I can have a little node also constructed on the side, inserted into this list, and make sure that it is pointing to this object, which is a separately existing object outside of the node. So the payload of the node is just a pointer to a real thing, right? So this is very powerful type of design in any situation where we need to be able to communicate between instances of things that we want to control, right? And so you can imagine a ton of different scenarios will exist here. So let's save this.